What's up, guys? So this is the first problem set of CS50 AI. This is an amazing course. It does require a good level of programming, so I recommend you've taken either CS50 or another introductory course to programming. If you wanna get a suggested solution after you've tried, check the description below. We also have an ebook on how to become a developer. And without further ado, let's get started. So the first thing you should understand to solve this problem is how to do a breadth first search or that first search. So it is using this approach here, which is in one of the slides of the lecture. So if you understand this, you're 80% done with the problem. So the first thing we're gonna need is to have something called a frontier. So think of a frontier as just like some sort of data structure where you can store the nodes that you are exploring. So let's get started. So we have a frontier and an explored set. So the first thing we're gonna do is add a node to the explored set. So in this case, we're gonna start from A. According to the algorithm, after we've started with A, what we need to do is to so we started with an empty set and we started the loop. So we now remove a node from the frontier. So we're going to remove A from the frontier, add it to explored state, and now we're going to add the neighbors of A to frontier. So we're going to add B. Okay, so after we've added B, we're going to add B to the explored set, and I'll add the neighbors of B to the frontier, in this case C and D. According to the algorithm, we should always be checking if we are at the goal state. If we are at the goal state, we're done. Okay, so we keep on doing. So we've added C and D. Now we remove C and put it at the explored set, and now we're gonna we remove D, we're gonna put F because F comes after D. Now we're gonna remove C and add E, right? Yes, we're gonna add E, and we're done exploring the graph. So this is a breadth first search. There is also depth first search. So before you even get started, I recommend you downloading the source code from the lecture, the maze example. Try it out, especially using the debugger, so you get a feel of how this algorithm works in code. So all this breadth first search, depth first search I just talked about is done with these three classes, the queue frontier and stack frontier. So familiarize yourself with those classes before getting started. Once you do get started, the most important function to understand is the solve function. So we're gonna do something very similar to this. So make sure you understand this, and degrees will be super easy. Okay, so let's take a look at the problem statement. So the problem statement states that we're gonna run our code with the name of the program plus the name of a folder, a directory, and we're supposed to write two names. One is the source name, the other is the destination name. Okay, so we want to know how many degrees of separations are between those two actors. So what does a degree of separation means? How many movies am I away from you? So observe that Emma Watson starred with Brendan Gleeson in Harry Potter, Brendan Gleeson with Michael Fassbender in Trespass, Michael Fassbender with Jennifer Lawrence in X-Men. So there are three movies, or in this case 3 degrees of separation between Emma Watson and Jennifer Lawrence. So that's what we're supposed to do. How are these problems gonna be represented? This idea of separation of degrees. We're gonna get 3 CSV files. So if you're not familiar with CSV files, that's why you export after you've played with Excel. So you have columns that have names of those columns, and then you have the data. So you have the ID, the name, and the birth. we have two folders, a small and large. I recommend you play around with the small first. That's good for testing. Then you go to large to test the final version of your program. We also have a movies CSV and a stars. So the movies has the ID of the movie and the year. The stars kind of matches both. So you have the ID of the person and the movie. So degrees has a lot of code already written for you, and if you explore a little bit, especially on load data, you're gonna see that all this data is gonna be stored in dictionaries, names, people, and movies that you're gonna be manipulating in your program. Okay, so what we're gonna do is very similar to Maze. We're gonna basically be implementing the algorithm that I talk here. Basically the pseudocode is already given to you, so there's not a lot of work you need to do. You just need to change a couple of lines. So we're gonna start with a frontier. What does a frontier looks like in terms of code? We're gonna initialize a queue frontier. Let me open this utils.py so you take a look. So the queue frontier inheritance from stack frontier, and it's basically a list. So that's pretty much what we're initializing, a list. Okay, so after we start, I'm gonna create a node. So a node is basically this circle that we observe here, but the node here just has a. We can have nodes with more items, a and a number and other properties. So our node will be a little bit more complex. We're gonna have a state, which in our case will be the actor, the initial actor. We're gonna have a parent, so who came before us, and an action, which in our case will be the movie the stars starred in. So we're gonna add that first actor to our frontier. Let me use the debugger so you guys get a feel of how this actually works. So I'm using CS50 IDE, which is a online ID provided by CS50, but you can do the same thing on VS Code. Both work great. So I'm gonna write degrees.py and the name of the folder I'll be playing around with, which is small. Okay, so let's take a look. A small arrow showed, which is normal. So I'm gonna put Kevin Bacon and Tom Cruise. Okay, so let me step over, and now let's look at our queue frontier, frontier. So if we look at our frontier, it's like a list. I showed you guys it was a list, and the list has only one item at index 0. The list has state 102. What state 102? If we look at the stars.csv, 102 is the ID of Kevin Bacon, which is the actor that I wrote as a start. So far so good. Where is it getting this 108 from? This is all done for us on the main function. So it calls this function person ID for name that replaces the name of the actor we wrote to an ID. So that's what we have right now. We have a frontier that has just the source actor. So we're basically following this pseudocode. So we start with a frontier that contains the initial state. In this case, that is the Kevin Bacon actor. And then we have also, we're gonna have an explored set that keeps track of the nodes we've explored so far. And now we're gonna have a loop. So in the loop, the first thing we have to do, according to the pseudocode, is to basically repeat over and over again. We're gonna check if the frontier is empty, and if it is empty, we're gonna throw an arrow. So we're doing this first step. After that first step, we're gonna remove a node from the frontier. Just like we did with the first graph, where we remove A, we're gonna remove a node from the frontier. and we're gonna mark that as explored, just like we did with A. We got A, added it to the frontier, and then made it explored. Okay? After that, this is the gist of the problem. We need to loop over the neighbors, and there is a function, fortunately for us, that gives us the neighbors that have started with that person. So this will loop over both, that will give us both the person that started with Kevin Bacon, all the people that start with Kevin Bacon, and the movies that those people starred with him. And then we need to do a check. We need to check if the frontier doesn't already have that person and if it's not being explored. Otherwise, we're going to have an infinite loop. That's explained more in depth in the lecture. So let me put a breakpoint here so you guys see what I'm talking about. So basically right now, my movie ID is 112,384 and my person ID is 200. So let's see who is 200. 200 is Bill Paxton. So that's a person who starred with Kevin Bacon. That person hasn't been explored, but that person is also not our target. It's not Tom Cruise. So we're gonna add it to our frontier and keep exploring options. Okay? So now if you look at our person ID, now it's 129. 129 is Tom Cruise. So now you're gonna see that this if statement is gonna be true. So if I come here, my child state equals my target. So now we begin the process of adding it to our answer. This is where parent comes handy because we need to backtrack. So we're gonna have the answer, but we want the entire path from the beginning to the end of actors and movies. And that's why parent is important. It kind of creates a tree where we can track every single person between the source name and the destination name. Since there is only 1 degree of separation, this will be easy. So we're gonna have just one iteration of the while loop and we're basically done. So we have a solution. If you look at our solution, it has just the movie ID and the actor ID as a tuple, and we return that, and if we run, it's gonna say that there is a degree of separation between Kevin Bacon and Tom Cruise, and they starred in A Few Good Men. If you had more degrees of separation like Emma Watson and Jennifer Lawrence, then this while loop would loop a couple of times. The reverse function is important because we're gonna have it backwards when we're done. We're gonna have the last actor, but we wanna begin with the first one. So that's why we reverse. Another important mistake that I see a lot of students doing, and this is suggested in the hints, is that you can check. So he talks about that in lecture, we check a goal when a notice pop up from the frontier. So that means that we basically would have this if statement not inside of here, but somewhere up here. So after we remove on line 112. But if you try this with the large data set, you're gonna see that that's gonna take a long time because this is less efficient than checking inside of the for loop. Inside of the for loop, you kind of short circuits the exploration. As soon as you see that one of the child is the target, stop exploring. So that way we can save computer cycles and solve the problem much faster. Okay, so this was degrees. This is a very good problem to get you familiar with a lot of techniques like breadth first search, depth first search. And if you have any questions, you can ask here on the description, on the comments, or you can also schedule a 30-minute call for free with one of our instructors on the description. And that's it, guys. So I hope you guys enjoy and see us in the next few videos. All right, see ya.